Hi everyone, and welcome to Biology Professor. Today we're talking about Koch's postulates. Koch's postulates are a set of 4 criteria that were established by a guy named Robert Koch. There's a little bit of confusion regarding how his last name is pronounced. Some people say Koch, some people say Koch, some people say Koch. So depending on your teacher, you might hear it pronounced differently, but I'm going to call it Koch's postulates. These are a set of 4 criteria that establish a causal relationship between 2 things, specifically between a pathogen and a disease. So basically, these 4 criteria help determine that a specific bacterium, for example, Bacillus anthracis, causes a specific disease. For example, anthrax. Let's look at these 4 criteria. First, you have to find the candidate bacterium in every case of the disease. So if we go with our example of anthrax, every single time you have someone with anthrax, you have to find the specific bacterium that you think causes that disease in every case of that disease. Next, you have to be able to isolate the bacterium or the pathogen from the host, and specifically, you have to be able to isolate that bacterium and grow it in pure culture. That means you have to isolate the bacteria from the host and grow it on agar media or in liquid media in a laboratory where you know that you are growing just that one species of bacteria and no other contaminating species. Then you have to show that the cultured bacteria from step 2 you have to show that that cultured bacteria causes the same disease in a healthy host. This would mean taking this bacterium that you're growing in pure culture and then injecting it into a healthy subject, usually an animal model like a mouse, to see that it causes the same disease in that healthy subject once you've infected it with this bacterium. And then finally, the 4th criterion is that you have to isolate that same bacterium from the experimental subject. So, once you've taken the bacterium growing in pure culture, infected a healthy subject with it, to show that it causes the same disease, you then have to be able to re-isolate that same bacterium from the experimental subject. This proves definitively that the original bacteria that you found in every case of the disease is capable of causing that same disease in an experimental subject. And these are Koch's postulates. Now, there are a couple of issues with Koch's postulates. First of all, with step number 2, not every pathogen is able to be grown in pure culture. For example, the bacteria that cause syphilis and leprosy are very difficult to grow in artificial media. Also, viruses. Viruses cause a number of diseases in humans, but because they are obligate intracellular parasites, they're not able to be grown in pure culture. They have to be grown in cells. So that makes it very difficult or impossible to fulfill step number 2 with viruses and some of those other types of bacteria. Also, for criteria 3 and 4, you've got this part right here where you're supposed to show that the bacterium or the pathogen causes a disease in a healthy subject. This isn't always ethical, especially with humans. You can't go take a healthy human inject them with a serious pathogen, and see that they get a disease. That's really not okay. But this is why we usually use animal models for this step. However, there are some pathogens that infect humans but don't readily infect animals, making it difficult to carry out these steps with those pathogens. But other than that, that's how Koch's postulates work. That's how we are able to prove that a given pathogen causes a given disease. And of course, determining what pathogen causes a certain disease is the first step in learning how to treat the disease and how to prevent it. So you can see how Koch's postulates are very, very important. So that's it for today. I hope you learned a lot, and thanks for watching.